FDRMOVE, a component of Innovation Data Processing's suite of business continuance solutions. FDRMOVE provides an easy, safe, and fast way to move ZOS datasets to new DASD systems, consolidating the datasets onto larger volumes with minimal or no disruption to the datasets. FDRMOVE provides three operations for the movement of ZOS datasets. Firstly, move and FASTMOVE. The move operation is used for those datasets that are inactive or periodically inactive, where high-performance I/O can be used to move the datasets to new DASD volumes. FASTMOVE makes use of existing hardware replication facilities like FlashCopy, TimeFinder, and Snapshot for time-critical datasets that can only be made available to FDRMOVE for extremely short periods. Shortly, we will look in further detail at both operations to see how quick and easy both processes are. SimMove lets you validate a move or FastMove before running the operations for real. We recommend you run a SimMove first, as it will check and validate syntax, identify the datasets that will be moved based on the selection criteria, and inform you of other systems in a DASD sharing environment that will need to participate in the operation. FDRMOVE is able to move many types of datasets, including single and multi-volume VSAM and non-VSAM datasets. The datasets are constantly monitored throughout the move or FastMove operation and are automatically moved to their new destination as they become inactive. SMS-managed datasets can be moved to new SMS-managed volumes in an existing or new storage group, and non-SMS datasets are also easily and quickly moved to new non-SMS-managed volumes. Datasets are selected and moved based on fully qualified dataset names and name filtering, either using a catalog or VTOC search to create the list of datasets that will be moved. Datasets can also be moved based on their size, the storage group they are assigned to, or individual volumes or groups of similarly named disk volumes. So far, we've discussed briefly the different options for moving datasets based on their activity and availability. Let's now look in more detail at the move operation of FDRMOVE. The move operation runs as a batch process and moves the selected inactive datasets to a new disk volume or volumes as specified in the job. FDRMOVE constantly checks to see if any active datasets that are eligible by selection become inactive. As they do, these datasets are also moved to the new disk volumes. The move operation continues until all selected datasets have been successfully moved or you decide to stop the job. There is an unmovable table that should be used to keep datasets from moving with FDRMOVE, such as the RACF database, but which can easily be moved with FDRPass if required. In the following example of the move operation, datasets from 5 volumes will be moved and consolidated onto 2 larger volumes in a new DASD subsystem. Once the FDRMOVE job is submitted, Move checks to see which datasets meeting the selection criteria are inactive, and it will move eligible datasets from up to 5 volumes at a time, automatically handling the cataloging of the datasets to their new volumes. During the move operation, it is possible to monitor the progress of the operation using the supplied ISPF monitoring panels. From here, you can determine how many datasets have been moved so far, and if any currently active datasets meeting the selection criteria will be moved when inactive. The monitor panel also provides the active datasets name eligible for selection, the volumes the datasets reside on, and the job or jobs that currently have the datasets open. As the remaining datasets become inactive, FDRMOVE will move these to the volumes in the new DASD subsystem, and once the moves are complete, the job ends successfully. Move is a quick operation, as indicated by the following example, where FDRMOVE, using the move operation, was able to move 2.5 gigabytes of data spread between 600 datasets in about 4 minutes. Sometimes datasets remain active for very long periods, with only a very short window of opportunity to move these datasets to new disks. If this is the case, then FDRMOVE's FASTMOVE operation lets you move datasets very quickly to new volumes with minimal downtime. The FASTMOVE operation again runs as a batch process, initially calling FDRPass to move the volumes containing the datasets you want to move to a staging or set of staging volumes called the transit station, designated on the new DASD subsystem. As applications are closed or end, the inactive datasets are moved from the transit station volumes to new disks within the same disk subsystem using hardware replication facilities like TimeFinder, FlashCopy, and Snapshot to complete the copy rapidly. Datasets need only be inactive for seconds for the FASTMOVE operation to complete, enabling applications to be quickly restarted. FDRMOVE handles the recataloguing of the datasets, and on completion of the moves, the volumes moved to the transit station are automatically returned to their original addresses. The following example displays the various stages a FASTMOVE goes through to complete a dataset move. FASTMOVE is started, selecting datasets on the 3 volumes, which are currently active. As in our previous example of the move operation, 3 of the 5 volumes in the existing DASD subsystem contain datasets that are active for extended periods, with only a small window when applications are closed and the datasets become inactive. In this example, there are enough transit volumes to move all the volumes containing the active datasets to the transit station volumes. Therefore, FDRPass moves all 3 volumes containing the selected active datasets to transit station volumes. Once a dataset becomes inactive in the transit station, the dataset will be instantly moved, taking advantage of the DASD hardware replication features mentioned earlier, to a specified disk address in the new DASD subsystem. FDRMOVE again takes care of cataloging any datasets to their new volumes. Progress of the FASTMOVE can be monitored using the ISPF monitoring panel. Here, we can see an example where 2 volumes have been moved to the transit station, meaning FASTMOVE is waiting for datasets to become inactive before moving them to the destination volumes. Also note there are no volumes being moved or currently waiting for transit volumes. When the dataset has been moved from the transit station volume to its final destination, the volume is automatically returned from the transit station to its original location. As the datasets on the other volumes in the transit station become inactive, they too are instantly copied to new volumes in the DASD subsystem. The FASTMOVE is effectively complete, and all applications using these datasets can be restarted. And the volumes in the transit station are also automatically returned to their original addresses, freeing the transit volumes to enable running more FASTMOVEs. The FASTMOVE is now complete. FASTMOVE performance is extremely quick. Taking advantage of hardware replication features, FASTMOVE can typically move terabytes of data in minutes. In this example, 250 datasets occupying 1 terabyte of disk space was moved in around 1 minute. Move and FASTMOVE allows you to move the majority of datasets that become inactive, at least for a short period of time. However, some datasets never become inactive. But again, this is no problem as FDRMOVE includes FDRPass. FDRPass lets you non-disruptively move the volumes containing these types of datasets to your new disk subsystem. Volumes that typically contain these types of datasets include SysRes, JES, and active ICF catalog volumes. Volumes with linked list datasets, security database datasets like RACF, ACF2, CA1, and RMM Tape Master catalog datasets. FDRMOVE provides a function to dynamically expand the size of the VTOC and VTOC index, This facility can be used at any time, but is particularly useful when moving disk volumes to larger capacity volumes within a new disk subsystem. Therefore, the additional space on the larger volumes can be fully utilized without the risk of exhausting a VTOC originally sized to contain less datasets on a smaller volume. The following diagram graphically shows how the VTOC and VTOC index will be expanded. The VTOC is expanded to a size you specify, and the VTOC index will be automatically increased if it is less than 1/16 of the new VTOC size. Any datasets that fall within the extent range of the newly sized VTOC will be moved to free space further along the disk. This includes the VTOC index and VVDS. With free space now available after the existing VTOC extents, the VTOC will be enlarged to a size suitable for a higher capacity disk. In summary, FDRMOVE provides a safe, robust, and easy-to-use solution, making use of proven technology to move datasets with minimal or no disruption, exploiting and consolidating new DASD hardware, with the added ongoing benefit of load balancing and hotspot elimination for existing DASD. The easy, safe, and fast way to move ZOS datasets to new DASD systems and consolidate onto larger volumes, providing a total business solution for the rapid movement of ZOS datasets and volumes with minimal or no disruption.